So, what if I told you that the very best software isn't built to avoid failure, but actually to fail perfectly? We're going to dive into a pretty fundamental mindset shift, one that's all about mastering errors, not just trying to prevent them. Welcome to the fault-tolerant mindset. In this quote right here, it just gets right to the heart of it all. In software development, especially on the back end, errors aren't just a possibility, they're a flat-out guarantee. They're a normal, expected part of how the system works. Once you really truly accept that, it changes everything about how you build things. All right, so here's our game plan. First, we're really going to internalize why errors are the norm. Then, we'll get to know the 5 usual suspects behind most system failures. After that, we'll make the shift from reactive to proactive, dig into some robust strategies, and finally, we'll talk about building the ultimate safety net to catch anything that slips by. Okay, let's be absolutely crystal clear about this. It is never a question of if your application is going to fail. It's a question of when and how. That database connection you rely on, yeah, it's going to drop. That third-party API you need, it will time out. And your users, oh, believe me, they will find some truly creative ways to send you garbage data. Look, this isn't pessimism, it's just realism. So if you're going to build for failure, you've got to know your enemy, right? Well, it turns out most of the chaos in our systems comes from a small group of repeat offenders. Let's meet these failure 5, the most common types of errors you're going to run into. First up, we have the silent killers, logic errors. These are so dangerous because on the surface, your system looks like it's working just fine. There are no crashes, no alarms going off, it's just humming along, quietly doing the completely wrong thing, corrupting your data or messing up your business results. And this right here is a perfect example of why they're so scary. Just imagine a little bug that applies a discount twice. The app seems to be working great. Customers are happy, orders are flying in. But behind the scenes, the business is quietly losing money on every single sale. An error like this could go completely unnoticed for weeks, causing massive financial damage. Next on our list, database errors. Since pretty much every app out there relies on a database, these can be absolutely catastrophic. We're talking about the whole spectrum here, from the connection just completely failing to something as simple as a user trying to sign up with an email that's already in use. The point is, when your database goes down, for all intents and purposes, your whole app goes down with it. Modern apps are basically these big interconnected ecosystems. We lean on all these third-party services for payments, for sending emails, you name it. But here's the kicker. Every single one of those services is a potential point of failure that is completely out of your control. They can go down, they can slow to a crawl, and there's not a thing you can do about it. Except be prepared. All right, let's talk about input validation errors. Honestly, you should think of these as your frontline soldiers. This is where you stop garbage data before it even gets in the door. Is this really an email address? Is that quantity supposed to be a negative number? Nailing the stuff and handling it gracefully is often your first and easiest step toward a truly robust system. And finally, we have the good old configuration error. This is the classic, but it works on my machine problem. You know the drill. A developer adds a crucial new API key, it works great locally, but then they just forget to add it to the live environment. And boom, your app either won't even start or worse, it crashes the moment a real user tries to access that new feature. Okay, so we've met the bad guys, we know what we're up against. Now comes the big shift. This is the turning point where we go from being firefighters, constantly scrambling to put out fires, to being fireproofers, building systems that can handle the heat. And this quote says it all, really. Great error handling isn't some feature you tack on at the end of a project. It has to be a foundational piece of the design. You build the entire system with the assumption that it will break, and you plan for that reality right from line 1. All right, so we've got the mindset down. Now let's get practical. How do we actually build these fault-tolerant systems? Let's talk about some key strategies you can start using right away. See, true resilience is so much more than a simple check to see if the server is running. I mean, a server can be on, but totally unable to talk to its database, right? So a good health check digs deeper. It asks questions like, hey, can we actually run a query? Can we make a test call to our payment processor? We need to know if things are actually working, not just if they're switched on. Okay, so an error happens, your next move is absolutely critical. And it really all boils down to one simple question. Is this a temporary glitch or is it a permanent failure? Is it a little network blip that'll probably sort itself out? Or is it a hard no, like a user sending you completely bogus data? because your answer to that changes everything you do next. And that leads us to two totally different playbooks. If the error is recoverable and temporary, your strategy is to retry. But you have to do it smartly, using something called exponential backoff. Basically, you wait a little bit longer before each new attempt. Now, if it's a permanent, non-recoverable error, you do the opposite. You contain the damage. You don't retry. Instead, you degrade gracefully, maybe by switching to cache data or just disabling one non-essential feature to protect the rest of the system. But what about the errors you didn't see coming? The ones you didn't plan for, the totally unexpected failures that pop up deep inside the system. How do you stop those from causing a total meltdown? Well, that's where you need your final safety net. Think of it like a single, all-powerful bouncer at the front door of your application. Absolutely nothing gets past them. Their one job is to catch every single error, no matter where it came from, and make sure it's dealt with before it can cause a scene or leak sensitive info to the outside world. That's your global error handler. So here's how it plays out in practice. An error pops up way down deep in the database layer. But instead of crashing everything, it bubbles up through all the layers, through the service layer, the handler layer, until it finally hits that global handler. That's where it's caught. The bouncer grabs that raw, ugly technical error and then figures out what to do with it. And this is really where the magic happens. That global handler acts like a translator. It takes some messy technical database error like no rows found and turns it into a clean, standard 404 resource not found for the user. It sees that unique constraint violation error and just tells them, oops, looks like this item already exists. And for everything else, all the weird unknown stuff, it has a default. It just serves up a generic, safe, something went wrong, and most importantly, it keeps all your internal technical details under wraps. All right, let's bring it all home. What are the big things to remember? First, errors are gonna happen. It's a fact of life, so design for them. Second, think proactively, not reactively. Build defenses instead of just fighting fires. Third, that global error handler, it's your absolute last line of defense. Don't build without one. And finally, never ever show your internal system details to the user. That's just asking for trouble. And that's the final thought I want to leave you with. Building truly great software isn't about chasing some fantasy of zero errors. It's about building a system that's so tough, so resilient, that when things do break, and they will, it handles it so gracefully, so perfectly, that the system just keeps on ticking, and the user is never exposed to the chaos. The goal isn't just to prevent failure, but to master it. You ever notice how some apps just feel snappy and reliable, while others are laggy and seem to break all the time? Well, it's not magic. It's actually a powerful, kind of unseen engine working behind the scenes. Today, we're going to pull back the curtain on that engine. We're talking about background tasks, the invisible force that really makes modern software work. Oh, we have all been there, right? You fill out a form, you hit that sign up button, and you're met with this, the dreaded infinite loading spinner. And you're just sitting there wondering, did it work? Should I click it again? Or should I just give up and close the tab? It's got to be one of the most frustrating experiences on the internet. So what's actually going on here? Why does this even happen? Well, it all comes down to how the app is handling your request. So for this first part, let's call it the waiting game and see what's really happening on what we'll call the slow path. Okay, let's trace this problem step by step. Step 1, you click sign up. Easy enough. Step 2, the server creates your account. So far, so good. But then we hit step 3, and this is where everything can fall apart. To send that verification email, your server has to call a completely separate third-party service, and that is the weak link in the chain. Because if that email service is slow, or even worse, totally down, your server is just stuck. It's blocked, literally just sitting there, waiting. The result? The whole thing eventually times out and your sign-up fails. One little hiccup from an outside service just brought the whole thing crashing down. And this really just nails the core problem, doesn't it? It's not just some nerdy technical failure. It's a flat-out terrible user experience. You, the user, you did everything right. But because of a problem with some other service that you don't even know exists, your action completely fails. So how do we fix this waiting game? Thankfully, there is a much, much better way. We need a system that can take that slow, unreliable work and just offload it. Get it out of the main flow so our app can stay fast and responsive. And the solution is actually pretty elegant. It's called a queue. The work we're offloading is called a background task. The key idea here, the most important thing to get, is that it runs outside of your main interaction with the app. You click sign up, that's the request, the server's immediate reply is the response. A background task is just all the work that can be done later. It's stuff that doesn't need to happen in that exact split second. Honestly, the best way to think about this whole thing is like a simple to-do list for the app. Instead of trying to do everything all at once, the app just jots down a quick note. Hey, remember to send that email later. This simple analogy, that's really the key to understanding this entire system. Now, check this out. This is the same sign up, but now we're on the fast path using our new to-do list. You click sign up, the server creates your account, and this is the brilliant part, instead of trying to send the email right then and there, it just adds send email to the list. That's it. And immediately, bam, it responds back to you, success. From your perspective, the whole thing felt instant. The app feels incredibly fast. This whole system really only has 3 core players. You've got the boss, which is your main application. That's the producer who creates the task. Then you've got the to-do list, which is the queue itself. Think of it like a holding pen for jobs. And finally, you have the worker, or the consumer. This is a separate process, and its only job in life is to pick up tasks from that list and get them done. The boss, the list, and the worker. Simple as that. Okay, so the app feels faster. That's awesome. But you might be thinking, what happens if that email service is still down? Haven't we just delayed the problem? Well, that's a fantastic question. And this is where the real magic comes in, the power of retries. Right, so let's set the scene. Your sign-up was a success. From your point of view, you're happy, you're off using the app. In the background, though, our little worker picks up that send email task. It tries to do it, but nope, the email service is down. The task fails. In the old system, this would have been a disaster, but here, something totally different happens. See, the system is smart. When that task fails, the worker doesn't just give up. It says, okay, that didn't work, let's try again in a minute. If it fails again, it waits a little longer, maybe 2 minutes this time, then 4. This is a cool strategy called exponential backoff. It just keeps retrying, spacing out the attempts more and more, until finally, hey, what do you know? The external service is back online, the task succeeds, and the email gets sent. And the best part? You, the user, never had any idea there was a problem. So what this all boils down to is that our application gets 2 superpowers. First is responsiveness. The app feels instantly fast because it's never blocked by slow stuff. And second is reliability. Failed jobs are automatically retried, which makes the whole system super robust and resilient to those little external failures. And this pattern, it's not just for sending emails, not even close. It is the invisible engine behind countless features you use every single day. Let's look at just a few of these tasks out in the wild. All right, we've covered this one, but it's the classic example. Anytime an app sends you an email, a push notification, or a text message, it's almost certainly happening as a background task. It's just the perfect use case because it relies on an external service. Ever upload a new profile picture or video? The process of resizing that image into a bunch of different formats or encoding that whole video so it can be streamed, that's really time-consuming work. So instead of making you wait, the app just instantly accepts your upload and offloads all that heavy processing to a background worker. If you have ever been in a business app and clicked something like export to PDF or generate monthly report, you've totally seen this in action. The app will usually say something like, we'll email you when your report is ready. That's your clue. They're telling you it's a slow process and it's being handled by a background task. So, as we wrap up, it's really worth just taking a moment to appreciate this unseen architecture. It's a fundamental pattern that's just quietly working in the background to make our digital lives faster and way more reliable. All right, let's just recap the key takeaways here. Remember, background tasks run work outside of the main request. They use that simple producer, queue, consumer model we talked about. And doing this improves an app's responsiveness, making it feel fast, while also building in reliability with those automatic retries. This pattern really is the invisible engine behind so many features you use every single day. And so that brings us to the end. Learning about background tasks kind of pulls back the curtain on just one layer of the incredibly complex, invisible machinery that makes the internet work. It really makes you wonder, doesn't it? What other hidden systems are out there, quietly making everything possible?